Last talk before the party. Hang in there. We'll be talking about basically the easy findings within iOS, pen testing, and reverse engineering as well. Renderman was in here who was giving the, oh, there you are. We'll go through some things. I'll help you out. I added some things just right after your talk, just so you can see. But I'll be tweeting out the slides afterwards. Scripting XSS is my Twitter handle. And here are my slides as well. So if you want them right now, you guys don't, up to you guys. If you guys want to take pictures, there they are. Tiny CC, Hackfest. Everybody good? Okay. So again, my name is Aaron Guzman. Here's my email address if you guys need to reach me with any questions. I'm an OWASP Mobile Security Project contributor with the testing guide, as well as the verification for mobile as well that's coming out, which is new, completely new. I'm a technical reviewer for SANS Defending Mobile Application Security Essentials. I work with SecureWorks as my day job. I'm a board member for OWASP Los Angeles and the president for Southern California Cloud Security Alliance as well. So again, based out of Los Angeles. And I was also a part of a project as a lead technical reviewer for Practical Internet of Things Security, a book that released back in June. So a lot of research I do is within the realm of IoT security. So like DEF CON IoT Village, I spoke there last 2 years. Spoke at DerbyCon about IoT defenses and mitigations and exploits as well. And some of the demos I'll give are on the findings that I found with the mobile apps on some of these IoT devices. So it should be fun. So brief agenda, we'll start with some basic iOS fundamentals. Who in here is basically a mobile security researcher by day or even at night, or a bug bounty for mobile? Maybe half, 0.5? Okay, well, cool, no worries. That's why we're going to go through some fundamentals, and then we'll have some sort of foundation for you guys. What about like web application pen testers, or people who have expertise in web? Okay, definitely more. So, okay, we'll go through the fundamentals, and we'll go through the common findings that I go through, usually that are with certain types of frameworks that are being used, whether it be hybrid or some sort of native framework that an application is deploying. We'll go through that as well and what to look for. And then we'll go through a few demos. Even in between the main demo, we'll go through some of the demos on how to extract an application and the file structure. And then some of the tools that are free and open source that you guys can leverage. If we have time, we'll go through some questions. So iOS, primarily Objective-C. It's basically a messaging language there. So usually if you'll have a debugger like GDB, want to do some runtime analysis, you can always hook Objective-C message send to get basically what's getting sent to system level calls. There's also Swift. And you could verify a Swift binary. They put a little old tool command line command there that you can check if a binary is using Swift. But the only Swift application that I know that's written completely off Swift is Lyft, the ride-sharing app, like Uber, the equivalent basically, one of the competitors, I guess. All applications are signed, and that's to let the users know that the application is signed by a trusted source, which is usually Apple. Very closed environment as far as iOS and Apple's concerned, which leads to the app review process. It takes about a couple days, 2 to 3 days. And that's usually an issue for some people if they want to go with a full native application or a hybrid application. And we'll go through the reasons why in a little while, but keep that in mind. It takes a couple days. But with the app review process, what Apple does is goes through the application and make sure there's no private classes, not like let's say API documentation that's available that Apple exposes, and applications using, let's say, a private one that's, let's say a calendar within the calendar private class domain or some sort of personal private class. The App Store will basically deny the app to be published and then send it back to the developers. And again, that's a whole another review process, 2-3 days, and it can go back and forth if there's not enough justification or if they're using some sort of malware as well, some sort of malicious behavior, backdoor behavior, things that I look for. Even vulnerable libraries, sometimes if there's like a neglect within like OpenSSL, for example, those will be sent back. Definitely more stringent than the Google Play Store review processes. When you submit an app for Android, the same day it'll be published, and it just throws it in a virtual machine, and if it passes, it passes. But again, with iOS, there's a lot more involved, and again, because they want to make sure that only accessible APIs and approved APIs by Apple are being used and not going against their terms of service. So things to keep in mind. Again, with backdoors is something that's huge, but there are ways to get around it. Again, with hybrid frameworks, and we'll talk about how we can get around some of these impediments with the review process. But again, just something to note. Probably can't see it there because using VGA, but what we're looking at here is the info.plist. So whenever you're taking apart an application for iOS, the first place you're going to look is the info.plist. This defines the application, let's say function, the build, what it's targeted for, what API level. So if it's built for iOS 9.2, 9.3, it'll state it in this document. Right here is a Domino's pizza app, iPhone.ipa. I've been on this new research. I want some free pizza, so downloaded a bunch of the pizza apps. But anyhow, so for example, there is a long string here, and what that string is basically a permission to use the location. So Domino's is letting Apple know the reason why they need to use the location of the user, as well as why they need camera access, and they just released a new feature to take pictures of credit cards to automate the process of ordering, for example. But this is all listed here, and the microphone as well. So you can allow the use of microphone in order to interact with Domino's voice ordering. Again, this is all defined in the info.plist file. And at the very, very bottom, again, you cannot see it here very well, but there's something called URL schemes. What URL schemes is a way for third-party applications on an iDevice to communicate with this app. So in this example, we have Domino's, and it's Domino's Pizza. So Domino's Pizza is Domino's Pizza : / is a URL scheme. So if another application wants to interact with Domino's Pizza, they would call Domino's Pizza : / and whatever, I guess, public available calls for Domino's Pizza, the third-party application will make that. Again, all defined here. You'll find some security settings as far as something called app transport security introduced in iOS 9 and above, and we'll get to what that is and the settings that I'll commonly come across. Not only that, sometimes you'll even find API keys, oddly enough. This is in clear text. This is the Xcode version of the info.plist, but it's just an XML file. And again, you can't see it very well here either, but it's just a key value pair. And this is the same plist file, but this is the equivalent to the Xcode version. But again, it's XML file in clear text. First place you're going to look at, again, is the info.plist file when you're looking at an application. So the basics of iOS security and its architecture, I'm not going to go top to bottom here because we know that, let's say, Apple's root certificates are burned in during manufacturing. But what I want you to keep note, and we'll go through the sandbox, but to keep note is the secure enclave. And this is where Touch ID data, meaning with your fingerprint, as well as keychain data is stored. So keychain is secure storage for iOS. So what should be stored there is passwords, tokens, anything PII, credit card data should be tokenized, and then basically, or tokenized hash and thrown in there, not in clear text. But just keep in mind that it's within the secure enclave, and the secure element is for Apple Pay. But we're not necessarily focused on that, because for assessments, you'll want to see if an application is storing your credentials or your data securely. So you can dump the keychain if you have a jailbroken device. That's why I say if you have like a credit card and it's tokenized and it's hashed, and you basically can't unhash it and view that information. So if you want to make sure twice, double sure that the data within, even if someone has a jailbroken device, is basically unreadable, you can go that route. But as far as the application sandbox is concerned, for iOS applications, what they are just randomly generated home directories. So you have what's called a bundler container and a data container, and they're both separate directories within the file system. And so the bundle container will basically have the application binary, and the data container will have like the caches and supporting files and the temp directory. This is where a lot of data leakage happens, and where I find a lot of third-party data that I shouldn't, or I find data that's being saved on disk, again, that shouldn't be saved on disk. And again, I'll go through examples in a little while, but nothing really too fantastic about the sandbox. Again, just randomly generated home directories, and then separated from your data directories as far as the sandbox is concerned. But when you get an iOS application, the file extension is a .ipa file, and it's just an archive file, meaning it's just a zip file. So what you can do is just rename it to a zip, extract it, and you can view that info.plist file. And I'll go through it right now in just a second, but here is the basic layout of how, if you rename a file to a .zip, you'll get a payload directory. Within the payload directory, you'll have the application.app, which is basically where the binary resides. And I'll just show you that right now. So basic, I have some demo apps here. And I already renamed, this is a vulnerable app here. DMVA is what it's called. So I renamed it, I can rename it again here, just so you guys can see. Let's make a copy. Rename it to zip, use zip. Here we go, now you have that payload directory that you saw on the last slide here. And then here is the .app file. But all I have to do is right click, show package contents, and here we are. You see the application binary. Very straightforward. Here's actually the binary itself. This is what you would drop into like IDA or Hopper. To view the code, to basically reverse engineer and statically analyze the code. And also, if it's a hybrid app, you'll see some supporting JavaScript files, or let's say some Cordova files, and we'll go through what that is in a bit. But as you can see, just pretty simple, pretty straightforward. And that was a regular IPA file. Whoa, where'd this go? Getting jQueried right now, it looks like. There we are. All right, so basic file structure, we talked about that, very easy. And there's also some metadata files in there. So I did mention app transport security, and this is within the info.plist file. And what app transport security is, was introduced in iOS 9 and above by default. Apple's enabled this. So what developers have to do, and third-party developing firms, is they have to explicitly deny or turn off this setting if they're going to use HTTP, or specify domains that will use HTTP. But not only that, so the point of app transport security is it's basically a secure by default approach by Apple to only use TLS 1.2 and cipher suites that only support forward secrecy. Now, what I've come across, I haven't seen an app really do it right. And I'll show you an example in just a bit. But usually, there's a setting called allow arbitrary loads, which means to disable app transport security altogether. So again, this was introduced in iOS 9, and jumping in, and I'll show you some examples in just a bit. It should be coming up pretty soon. But as far as the new enhancements, this is something to keep note of. And with iOS 10 that just released not too long ago, some updates with encryption is basically disabling RC4 cipher suites, legacy RC4 cipher suites, disabling SSL v3, finally, by default. And then also, if you're using a protected class, meaning, like I was saying, the calendar data, if you want to access that, you actually have to have that long string in the info.plist file. Otherwise, the app just fails. Not only will your app get denied, but the app will just exit. That's a new requirement. Before, it was almost kind of loose and going back and forth between the developers and the App Store from Apple. But now it's a requirement. So any type of protected class, like I said, there's calendar, there's other things, your mail, you want to access personal data, your contacts, that has to be defined as to why you need that from the developer's perspective. Any questions? Feel free. Okay. So we'll just jump right into the common findings because this is where the meat is at here. And it starts with SSL and TLS issues. Specific libraries and frameworks that are used, which is AF networking, version 2.5 and 2.5.3 and below, not good. They do there's a lot of issues. They allow any SSL certificate by default. They're insecure defaults is what it is. And there's also ways to turn off SSL pinning. Not many apps do SSL pinning, unfortunately, unless it's like a banking app. Hopefully medical, but not always. I know for sure IoT devices and let's say door locks. Actually, I found one door lock provider that did do SSL pinning, and I was happy to see that. And it was a big one, Kwikset, Kivo locks. And so the only way to get around SSL pinning, you have to jailbreak a device and use a tool called SSL kill switch too. Only way to get around it, and that's the only way you could proxy the traffic. But still, good for them, as far as doing SSL pinning. Allow any root certificate for these are, I guess, the APIs that you would look for when you would drop it into Hopper to basically reverse engineer or statically analyze the code, or IDA. Actually, the free version of IDA does support mock-O files, and that is what IPA files are mock-O files. You can reverse engineer an iOS app for free. And all the tools basically are free, and all the tools I'm going to show are free. Something to keep in mind. So these are something you basically want to copy and paste into a search function or a find function, or even you could even do strings if you'd like with the application binary. And again, with AF networking, allow even invalid SSL certificates. Sometimes developers will forget for production builds to take this out. Very common, and it's really easy to mess up SSL and TLS issues because you could use multiple libraries in iOS, and it'll override another library setting. You basically won't even know which one's being used. And I see that a lot when I'm doing a lot of pen tests. And again, we talked about app transport security, but I believe right here is the example. Let me show you the example really quick here. Here's the example of allow arbitrary loads. And this one is set to yes. So you can use HTTP freely. You can talk to third-party domains. It's not restricted to one. Again, very common setting, unfortunately, and hopefully we'll see a change soon. But as far as testing for certificate validation or CA validation, here are some steps that my buddy Tony, who's the director of security for Tinder, he's actually was working with LinkedIn when he did this research, talking about mobile SSL failures. Now, again, basic steps to test if the certificate is valid through a CA validation through Burp. You basically configure your app to use the proxy, so you go through like the Wi-Fi settings, set the proxy settings up, configure Burp. The Burp listener generate a CA sign per host certificate, and you're not even installing the certificate on the device yet, not even navigating to Burp's listening IP and cert URL. And then from there, you'll verify to see if there's any browser warnings, step through parts of the app, and then if you see HTTP traffic in Burp, then the app's failed. So simple steps, not too hard. It'll probably take a couple minutes. The best thing about it is that you don't even have to have a rooted device to test this, or a jailbroken device. For testing hostname validation, again, similar steps. Basically, the only change you're going to do is generate a CA certificate with a specific hostname. And you can set that hostname to whatever a third-party domain, your domain. Kind of play with it to see if you see any browser errors, and step through the app. And again, if you see any HTTPS traffic in your proxy, the app's failed again. So pretty simple stuff. Not too hard. Again, you don't have to have a jailbroken device to do these types of tests. Usually what I'll do, or what I've done, is I've gone through like small banks that have that have apps, and I'll just do a quick check. And sometimes I'll just write a quick note to them, like, hey, you guys aren't, not only are you guys not doing pinning, but you guys aren't doing hosting validation or doing any certificate validation at all. Usually I'll get okay, thanks, but I did my part. I just checked it out really quick. Again, because it's pretty easy. So some iOS SDK or API vulnerabilities, these are known. So for handle open URL, this is what the URL schemes use. So as far as inter-process communication for iOS apps, and this is basically the delegate, the app delegate is what they call it. But now it's interesting with URL schemes and inter-process communication with iOS. So usually if you click something, let's say a phone number, it'll ask you if you want to call. If you click on a Skype thing or a certain app or Spotify or SoundCloud, it'll ask you if you want to open it. But sometimes when you actually accept the first time, it doesn't ask you again, and you could spoof that. And that's an issue. But some of those issues are because of handle open URL. Again, it doesn't tie back to the bundle ID of the application. Other than that, you have the UI web view. So when I was talking about hybrid, again, we'll go through what hybrid applications are and frameworks. It's basically the web on your mobile device and using UI web view itself. And a function that I look for is string by evaluating JavaScript from string is basically a JavaScript blob or piece of JavaScript code that's ran on the device. So it could be arbitrary, and you could just check if are they doing escaping, are they doing output encoding, because you can get access to the full application sandbox from there. And by default, for if you're using web views within an application, all domains are allowed. There's no restrictions to domains that the application can speak with. So things to keep in mind again when you're looking through an iOS application looking for API or SDK vulnerabilities. So with mobile, SSL, well, data in transit is an issue, and data at rest, saving data is an issue for developers. Why? I'm not too sure. Like I said, there are APIs available for developers to exercise to securely send and receive data for SSL TLS, as well as saving data on the device using the keychain, for example. So typically what I find are private keys, encryption keys, private encryption keys basically, some secret values, personal values, passwords, OAuth tokens everywhere really, JWT tokens. Usually if you see something that starts with EY, just pop it into what's called JWT.io. It basically decodes the JWT token. Anybody familiar with JWT? A few people? It's everywhere. Be prepared because it's there. And they're being sprayed around, whether it's JWT or OAuth tokens. How many are familiar with OAuth? Okay, definitely more. Okay. OAuth too. Yes?
Aaron, do you see like JWSs or JWEs on top of JWTs at all?
I haven't. I have never. Not even a banking application. Not even a banking application. Yeah, it's very sad. There's no JWS or JWE on top of these, basically digital signatures, basically so they're not tampered with. And when you decode these JWT tokens, you can tamper with them, you can edit the values and re-encode them. They're base 64 encoded. There's just 3 different parts to a JWT token. And we'll get to an example in a bit. But other data where developers store personal identifiable information, your address, passwords, are SQLite databases. There's something specific to iOS, which are called Realm databases. And developers, again, seem to think because it's only iOS that no one's going to look or figure it out. But you go to the App Store, and there's a Realm database browser, free. So you just got to transfer the file from your iPad or your iDevice over to your Mac and view the files from there. We also have binary cookies, which are interesting and saved on disk. And again, I'll show you guys an example of that as well. And you have cache, temp directories, file system cache data as well. where basically all this data is being sprayed. So whenever anything is stored within a plist file, they're using NS user defaults. And again, I might show an example if I have time of one app, let's say Domino's, storing my OAuth token in an info.plist file in clear text with long-lived expirations like 20 years. But again, and you also see people, I say the tokens being sprayed, meaning I'll see them not only in the URL, I'll see them in their HTTP headers, I'll see them in the keychain, I'll see them cached. So I see them everywhere, but yet they try to do the good thing and save it in the keychain, but again, it's being sprayed around. For reasons I'm not too sure, but again, we'll go through some of those findings. My girl Oprah. So I'll throw a couple of commands at you guys, just so you guys can have them in your reference. To find bundle IDs, meaning what applications are running. If you SSH into your device, your iDevice, and you run this command, you'll basically see whatever app, like dominoes.app, ring.app, whatever, hackfest.app, meaning .app. And then, as we talked about, within that directory is the application binary. So you can also get a decrypted iOS app that way as well. But that's the first part. Otherwise, you're not going to know. A bundle ID is basically the randomly generated home directories. Otherwise, you're not going to know what you're looking at. If you want to find all plists within iDevice, you want to find all SQLite database and realm databases, throw a little regex in there, find everything .db, .realm.sqlite. And again, this can all be scripted too. Something that I've done, but there's not many tools to be ran on the iOS devices themselves. But again, bash scripting is pretty easy. There's even Python on iOS devices, and Ruby. There's something called snapshots. So this is also another side channel data leakage. If you basically double tap your home button on your iPhone, there's a screen that's being showed, and if you have, let's say, most banks. Bigger banks, as far as U.S. banks are concerned, they'll have it masked with a splash screenshot, just saying Chase or Bank of America. But you'll have smaller other third-party banks that won't, and you'll see your balances basically. And again, other applications can access that data, and it's cached as well. And it could be username or passwords too. When we're talking about binary cookies. There's a Python script that I'll show you guys as well that'll decode what's in these binary cookies. And again, a lot of sensitive data is always stored in here, and long-lived tokens. And again, tokens are also stored in these binary cookies on top of all the other places I noted. Local storage. Who knows HTML5? Yeah. So if you're using a hybrid application, local storage is very alive and real, saved on disk. Even if you delete the app, it's still going to be there. So that's something we also look for data leakage. So here's an example of Blowfish Private Key. At the bottom, I try to redact a little bit of it. But what it is an XML file, configuration file, that a company is using within their bundle directory there. And you guys can use my cursor. Here is the configuration file, service factory, and here is the Blowfish private key. Here's the value. So for whatever reason, they decided to roll their own crypto. Never a good idea. The platform has enough available. And this is their credential manager too. So it's an emoji. Oh, this looks awful. What this is a JSON file. So in this same, not that directory, in this same directory here, this bundle directory, no tool is going to find this, by the way. You basically have to be nosy and snoop around. And what I found was a .json file. It was basically a settings file, and it was a settings file for a hybrid application. So it had, you can't see here, but it says client secret, client encryption key, client ID. So client ID and client secret for OAuth is basically a way to retrieve access tokens. So hard-coded. You have API key here. You have the Android sender ID. You have a number of different IDs and passwords and keys in here, all in clear text in a JSON file. And just because it's in the app sandbox, they think it's secure, but definitely not. And this is true for all applications that they deploy. For example, for this application, so you have a client ID and client secret, and I say they're not using a third-party OpenID server for federation, for example, or application delegation. There's no need to basically hard code this client ID and client secret. They can use better OAuth authorization flows, for example. But again, it's sprayed everywhere. Keys, private keys, infinite facepalm. You guys like that? Find myself doing that on mobile assessments. IoT, for sure. So I've been talking about hybrid, and I haven't really explained it to the full extent, or at least partial. And what it is basically iOS, the web, HTML5, heavy JavaScript, CSS, and then there's Android, and it's all in one code base. So that's usually attractive to people. And not only that, again, JavaScript, you think of JavaScript. You think about secrets again, people storing secrets in JavaScript and trying to obfuscate them or minify them, thinking it's going to work. Doesn't work. I'm still going to find it. And if you just Google deobfuscate JavaScript, just throw in the blob and you can just see actually all the code. But again, as far as JavaScript code and JavaScript secrets, and just do a find or a grep in there. But again, heavy HTML5. HTML5 has its own issues, which we'll get to in just a minute. But if you're using a hybrid application, you're gonna use some sort of web runtime. Usually use a WebKit or Crosswalk. And then we talked about code bases, just one code base. Something that's important to note is these hybrid frameworks have their own marketplaces and plugins. Third party, not regulated or not even reviewed for security or not even thought of by, let's say, like the App Store or Google Play Store. And this is third-party code. And there's even plugins, let's say, for example, with Cordova, a plugin to disable app transport security. And we'll talk about Cordova in just a minute. That's one of the most common frameworks being used in the hybrid world. But hybrid, as opposed to native, for the iOS, is basically just having native code, Objective-C, Swift, C, C++. Generally, you have more control of it, so better security for the most part. But you do have people go, and you can go from hybrid to native. Let's say like Instagram, for example, was once hybrid, but now they wanted more control over the camera features, so they chose to go native. Yeah, we'll get to HTML5 here. WebSockets. WebSockets are alive and well in mobile apps. Even proxying those things are a pain. We talked about local storage already. Web workers, file system APIs, getting access to the file system of the mobile device. WebRTC for real-time communication, chatting, video communication. There's a lot of insecure configurations within WebRTC that a lot of people mess up. And there's also encryption settings as well. But in the right circumstances, somebody can basically take control and scan your internal network using WebRTC. So that's cool. Keep that in mind. And there's plenty more. So obviously, the attack surface is much bigger if you're using a hybrid framework or using some sort of heavy JavaScript again framework. But one thing I didn't really talk about, which I should have, was the updating without redeploying aspect of hybrid. And that's why some people or some developers will choose to use hybrid over native, because it'll get to their users quicker. Not only that, if they're redeploying, JavaScript's in their control. So they can just update it real time, and now the app's updated. And you can even bypass the App Store's controls using a hybrid framework. And it's been done, and it's been demonstrated, and it's known. But again, if you're looking at an application, it can change from one day to the next, not even knowing. It doesn't have to have a full app update for it to be changed. So kind of scary at the same time. just because it goes around those kind of controls. Another big issue or a concern or something that I should have mentioned within the App Store process is every application that you upload to Apple is encrypted by their Fairplay DRM. So if you try to just go to iTunes and download an app, even with your laptops, you'll download the IPA file, but the IPA file will be encrypted. You try to do that zip trick I tried to show you guys. It's still not going to work because it's an encrypted file. But there are tools to basically get around that, like anything else. Free tools again, something called Clutch2, command line, Clutch2 -D, and then whatever app, and then done. So hopefully I get to show that as well. I just did it right before the talk, so you guys can see. Not very hard at all. So Cordova, again, one of the most common frameworks that I see out there. It's also known as PhoneGap. And we talked about the plugins and the plugin problems that's around there. And it uses Crosswalk as its web view or its web rendering engine. By default, Apache Cordova implements what's called domain whitelisting. So it can only talk to domains that are defined within its configuration file, because it has its own configuration file as well. So it adds on top of everything else. But something to keep in mind. You can also make exec calls, which is interesting. You're exposing basically command line calls. And I've seen issues where this has been exposed and applications being taken advantage of because of, let's say, not validating or verifying commands. And they'll it'll be a dynamic parameter, for example, and then an exec call will be made through Cordova. But again, to keep in mind, that's alive and real with Cordova. And something that's huge, and what I'm going to demonstrate with two of my demos, is by default, Cordova caches all requests and response in its cache database. So you've got to imagine responses and whatever application context. Let's say my car, which I did have fun with. It shows basically my personal information, my VIN number, where I live, where my car is at, my favorite radio stations. Everything just cached, and again, because they're using Cordova, and it was by default. And what developers have to do, unfortunately, when they're using Cordova, is use a plugin to disable that, which sucks. But it's because it's using NSL URL cache, and they have to create a cache policy to basically disallow caching, and also supply the correct cache control headers. Because if it's hybrid, it's going to be cached using like web technologies. Same thing. Very easy to mess up. Two places you have to configure that, but something to keep in mind with Apache Cordova framework apps. Caches all requests and responses. Here's an example of the configuration file and plugins used by Linksys, and it shows you their own like proprietary plugins that, let's say, they didn't publish to the marketplace. But they use their own, so they use something called Linksys Secure Storage, Linksys HTTP Request, Network Manager. But they also have known plugins like the whitelist plugin, in-app browser, for example, the Crosswalk Web View, because you can also choose to use WebKit if you'd like. Pretty simple, but it's something like, think about Node.js and the dependencies within Node.js. And it's funny because actually Cordova uses NPM as its package manager, just like Node.js. And with Node.js, you have something called packages.json, and it's the exact layout as this with what's needed module-wise for the application to run. And all you have to do is look through the Cordova plugin list and see what's updated, what's not, what has vulnerabilities and what doesn't. For Node.js, they have something called Node Security Project, and you can check that for the command line. But it's more manual for the Cordova plugins. But pretty straightforward, though. You can tell what an app is using. And again, I'll go through some tools where you can view this information pretty easily within a couple minutes. What's going on here? Okay. Here's basically a description of what Cordova defines a plugin. A plugin is a package of injected code that allows Cordova WebView, within which the app renders to communicate with the native platform on which it runs. So it sounds like cross-site scripting to me, and that's what a plugin is. So if you guys want to create a plugin, put it in the marketplace, have people download it, let's say calculator.js, and make it add some numbers, and then maybe some scary things in there. I'm positive it'll get by. There's no code review process for security. But this is how easy it is to plug in, to create a plugin for Cordova. It gives you, 3 steps there, 4 steps. Create an npm user, define your plugin, create your package. Pretty straightforward. And it does say injected code, so you're not seeing things. Again, you can't really see it too well, but here's the code review process to publish to the npm registry and to use a plugin. All it is basically check for error conditions, exceptions, nothing to do with security at all. And again, npm is basically a not third-party entity, not a non-profit organization, and they're not bound to any type of security regulation. So it's up to basically the users and developers to employ any type of security measures or security controls and validation when submitting their plugins. But again, if you want to create a calculator.js, throw it in there. It's not very hard to get it passed and downloaded by a number of different organizations. Something to note too, and this is within Cordova's documentation. It says Cordova does not support true certificate pinning, and it's basically the lack. And this one was for an Android implementation here, but it's lack of basically native APIs to do so. Whew, running short on time. Okay, hold on. Here's all basically the advisories. I'm not going to go through them for Cordova, so it's a very heavy researched area. There's like 5 highs and 4 mediums, all within the last year, by the way. It's my buddy. Okay, let me show you some examples here. I'll show you the first quick one here. Here is a finding that I sent to Subaru, which is the car I got earlier this year, and I saw I had a mobile app, and I was like, hell yeah, check it out. So, it was using Cordova. It was storing, what I basically did was copy and paste what they had that was interesting to me, and I just put it in this text file so they can see it. So I sent this video to them, and what I'm basically pointing at here is the handoff token. It said like mobile handoff token, and I was like, yeah, that looks interesting. So I like tokens, so we'll come back to that. So I pulled this cache database over to my Mac from my iPad. And then what I'm going to use is a free tool. It's called SQLite Browser. So just pop it open. I'm usually pretty nosy. If I see things in there, I'm looking at whatever tables are there. And then I usually click in the middle, because I don't know what I'm doing sometimes. So I'll just click in the middle, like I'm doing here. I'm like, oh, cool. Here's an HTTP request. What do you know? They're sending my token and my username and then everything in the URL. So I'm going to pop it in my browser, see what's going on here. That handoff token, still there. Hey, now I'm logged into my Subaru account. Very cool. What I forgot to notice, I blobbed this out because this is like all my personal, my VIN's right here, but it's fine. This services dropdown is where you can unlock my car door, honk my horn, do all the fun stuff. So, but we're not done yet. Click and log out. Throw it back in there, because it says I'm logged out, right? You have been logged out. Not ever. I'm never going to be logged out. Yeah, so again, storing data insecurely, not expiring tokens, not renewing tokens, not doing any of that. So that was a problem. I reported that to them. They fixed that, thankfully. I'm going to show you something that was very funny. So October 20th, I gave a talk at B-Sides LA on hybrid frameworks. And I've been trying to get a hold of these guys from Ring Doorbell, because they sell video doorbells from or at Costco's and Walmart's everywhere, and every like basically major retailer. So almost the same thing. For my finding, my email I sent to Subaru, I basically almost copied and pasted it and sent it to Ring. But there's more to this one, and you'll see. This one's great. But not only, oh, I forgot to say, when I was giving this demo over at B-Sides LA, guess who was in the audience? One of the guys was like, oh, this is the best presentation. Getting a free pen test. I'm like, you work at Ring? He goes, yeah, VP of security. I was like, oh, awesome. Someone cares. Well, I was like, I'm still going with the demo. So here we go. Same issue. I spit what was interesting to me in a text file. And again, another URL. I just put it up there. They have my auth token in the URL. And these two links, one of them is my doorbell history. And then another one is basically my devices in my network. Because like any other IoT device manufacturer, they scan your local network and want to see what's there. So here we are, going to go ahead and open this. And by the way, don't mind all those add-ons from Burp. I was just trying a bunch of things out. I actually had someone ask me, like, why do you have so many add-ons? I'm like, dude, I was just playing with it. So again, I'm nosy. I'm going to probably click in the middle again, maybe mess with some rows, do what I do best. Click in the middle. Let's do it. So again, same exact issue, not hard at all to find these things or even fix these things. But again, in this instance, this was showing my user ID and my token. And they're sending the token in the header too, and in the URL. But don't worry, there's more. And this is all, again, for storing data insecurely and caching that data, all requests and responses. So I think I went ahead and... So these are the two requests that I showed. Here's the auth token. Here's the doorbell history. And I think it's browser time. Here we are. Copy and paste that into my browser. Full JSON. And I see you guys recording, so it's still going to be valid. Just don't use my address, please. So if I answered it, the timestamp, if it was a motion, if it was not. And let's check the other one. Oh, and keep in mind, I even logged out of the mobile app before I even did this. So again, same thing, issue with session management. There is none. There's my home address there that you could have saw. And there's also like my first name and last name, but I put test account because this thing wasn't sitting on my, my front door. It was sitting next to me in my office, and now you know why. But look, I wasn't even logged into Ring account for the for the web, and I was still able to view it. But don't worry, there's more. All right. So I was proxying traffic with Burp. And again, don't mind all these plugins up here. I only have like 4 now. Since someone called me, I was like, oh. But anyways, look, you can see asynchronously they're sending this auth token too. And I guess that's their form of authorization. So I could have did it that way too. So again, they're spraying these tokens around. It's not the only manufacturer. There's definitely more, but I hate to pick on them, but they didn't get back to me for a month and a half. But okay, now what I'm basically looking for is when there's a motion, there's video that's saved and that's sent back to the iDevice, the iPad, whatever it may be. And I basically proxied that traffic, and I saw they were using good old Amazon. And I was like, oh, since they're basically not doing everything else correctly, let me just copy and paste this and see what I can do. It's still valid, not even expired. So there's me in my office. That's me. But yeah, unauthenticated. I sent it to my friend, and he was like, "Dude, are you serious? It's not tied to anything. Anybody, like anything's basically important for a doorbell is exposed and long-lasting." And I'm gonna try to factory reset now that you guys are recording, but my auth token. But again, examples what somebody can do if they're storing data insecurely. And again, they're easy. It's easy problem to fix. This is basically what you have to do. Come to my house. That was me when I found out. Real quick, here are some tools that I use. Mobile Security Framework. IDB is definitely the main one here. Frida and Cycrypto for runtime analysis. A ton of bash scripts. I gave you those commands there. Then your brain, obviously, if you want to be nosy, definitely check out the file system, see what's cached. And again, always trust but verify, and tools don't find everything. So again, that's why I say use your brain. So here's my contact info. Are there any questions before I close out? Yes?
So basically, the attack is that another application would access those files and could do what you do.
Yeah, another application, or obviously in a hostile network since you're sending it. And not only that, lost or stolen is usually an issue as well. There's also a couple different use cases, but I mean, for their product, you know what I mean? They should take the forefront and store that data securely and do it the right way the first time. But obviously, their web and mobile and their API and tokens are not tied correctly. Identity management access control, the AAAs, it's not happening with a lot of these OAuth frameworks, unfortunately. Yes?
What do you suggest about JWTs? Should we use cookies or not?
No, JWT is great. JWT is great. It's just if you're validating the signature to see if it's tampered with, that's the main part that no one's doing. You're just throwing it into let me see if I can show you. I have this little. So here was one of them. This was for, I don't know if it was Ring Doorbell, but here's one of the JWT blobs here. This one is not like everything else. There's usually more data in here. It'll have like a user ID. Sometimes they'll even have passwords. And sometimes this will also be sent to third parties. But again, this part is actually supposed to be in the payload, so they're not doing it right already for this company. But here's the signature as well. Oh, I can't show you. It's at the bottom. It's SHA-256. Any other questions? Well, feel free to message me if you guys do have questions. I'll go ahead and tweet out my slide deck. And if there are any reverse engineering questions, I'll definitely show you how to reverse engineer an app and client-side analyze the code. But thank you for your time.